Welcome to the Real Python Podcast. This is episode 81. Python 3.10 is here. This week on the show, two former guests and Real Python authors return to talk about the new version. Geir Arne Hjelle's article was posted to the site Monday, and it's titled Python 3.10 Cool New Features for You to Try. Christopher Trudeau's video course came out on Tuesday, and it covers the topics from the article with multiple visual examples of Python 3.10 code. Geir Arne and Christopher work together to create code examples of the new features used in both. We talk about more user-friendly error messages, structural pattern matching, enhancement to Python's type system, and much more. Geir Arne and Christopher not only cover the new features, but they offer advice about ways you might incorporate them into your code. We also discuss what you should think about before running the new version for your projects. This episode is brought to you by Snyk. Snyk is like Grammarly for your code. Secure your project with vulnerability scanning and automated fixes. Try Snyk for free at snyk.co/realpython. That's snyk.co/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Well, I want to welcome back Geir Arne and Christopher Trudeau. I'm excited to wrap up this sort of Python 3.10 week here, where we have Geir Arne's article and then Christopher Trudeau's course. We're going to kind of cover lots of these high-level features initially, and then kind of dive into some like little grab bag of additional things at the end. Thanks for coming back on the show.
Yeah, thank you so much for having me. It's always fun to be here.
Yeah, glad to be here.
If you're ready to dive in, maybe we could start with talking about the improvements, and this is something David and I have talked multiple times in the progression of Python 3.10 about better error messages in Python 3.10. But if you want to take that one first, Geir Arne?
Yeah, so one thing I feel like just with the new sort of like the annual schedule for Python, where they kind of do the releases more regularly and so on, I think we kind of get the news as well of new things happening, so that when you run the news show, we kind of have heard about some of these things.
Yeah, it's been neat.
Essentially, better error messages. It's an initiative, I believe, by Pablo Galindo Salgado, who is the release manager for 3.10 and 3.11, in essentially working on some of the error messages in Python that sometimes may come off as not very friendly. You kind of leave out the quotation mark or something, and it just tells you something like EOF at end of, or EOF, whatever that means, and things like this. So now they're kind of going in, especially on the syntax errors, to make them more precise and more helpful, and actually give you suggestions on what is happening. So, for instance, if you are leaving out a quotation mark, that would kind of mean that Python, the parser just runs to the end of the line. That would be an EOL in the old syntax, but now it will kind of actually tell you that there's an unterminated string literal, and it'll point to where it started and things like this. And that they've done a whole bunch of these. Also, if you're kind of messing up, especially for dictionary syntax or similar things, where you might leave out a colon between your items or a comma between items and things like this, it will precisely tell you exactly what you've done, so you can kind of go in and fix it instead of being confused by. In the old days, it will typically just say something like invalid syntax and then give you a line number that was often just wrong even.
Yeah, it'll be like maybe like the last thing that it recognized, right. Which is kind of weird because that's probably correct, but like everything after it may not be. So it was very confusing.
Yeah, and it's, I believe it's partly due to the new parser that was introduced in the latest in Python 3.9. The old parser was kind of very naive and kind of could just move forward essentially. So it couldn't really backtrack once it hit something that it didn't understand. So it would kind of often give you the errors on the next line when it finally realized something was wrong, especially if you're inside some kind of parentheses or brackets or something like this.
Yeah. So not only you were talking the parentheses or the quotation marks, but also like, opening and closing of the brackets and pointing to where they started.
Exactly.
I'm really excited about this. Were there other examples that you noticed, Chris?
Yeah, the feature there that I kind of actually had some fun with while I was writing up the course was the suggestions feature. This is something that I've seen in a couple terminal shells now, where you make a typo and it says, "Oh, did you mean this?" instead.
Yeah.
And they've added that support to the error messages as well. So if you import the collections library and then try to grab named tuple out of it and you spell named tuple wrong, it'll say, "Did you mean named tuple?" And when I was writing up some of the sample code for the course, it actually helped me once. I don't remember what error I did, but I typed something wrong, and it was like, "Oh, you meant this," and I'm like, "Oh yeah, I did. Thank you. That was helpful." So it's a little bit like what do you call it in the editors where they
the autocomplete.
Autocomplete, yes. Thank you. It's a little bit like autocomplete, but inside of the REPL. So that was kind of a neat little feature. The other aspect of it, I find lately I've been on and off helping one of my younger nephews learn some of the coding, and a lot of the syntax errors just 13-year-old kid doesn't get it, right? Like a syntax error, invalid something is not particularly helpful. And now you see things like I think you forgot brackets, or this should have been double equals instead of a single equals. Much more readable, much more friendly for new coders.
Yeah, the term "better" is sort of an interesting blanket statement for error messages, in the sense that it's like friendlier or more specific, or lots of these things that are kind of under that umbrella of better. But yeah, it's nice to see these changes.
Yeah, I think this will both make it much easier for beginners, but also for us more experienced coders, that it will cut down on my debugging time, essentially just pointing me directly to whatever I messed up. So I'm really looking forward to it.
Yeah, cool. So the other one that has come up on the podcast multiple times up to now is the structural pattern matching. Chris, do you want to talk a little bit about that?
Sure. So if you've come from other programming languages that have a switch statement, this is that on steroids. If you're not familiar with it, essentially it's a alternative to large if then else blocks. There are two new keywords introduced, one called match, the other called case, and you declare one of these pattern blocks by saying match and then giving it a thing to match, and this is usually a variable. And then inside of that match block, you have one or more case statements that are patterns, and if the pattern fires, then the block underneath that case statement is what gets executed. So in the course, one of the simple examples that I use is I match on name and has a case with the string Guido. And if the person's name is Guido, then it prints I'm not worthy. And if the case is the default case, which is everybody else, which you do with an underscore, then it just says hello to you. So this is a really simple case. And honestly, it doesn't, it's not much of an improvement on if else. It's about the same amount of code and looks about as complicated. But that's sort of the basis of it. Where this tool gets really, really powerful is the patterns that you can match in those case statements can get really, really crazy. So you can match the integer inside of a dictionary, inside of a list of dictionaries, inside of a class, and it does that without any problems. You can match specially with data classes. And because data classes know the order of their own child parameters, their arguments, it will actually populate those for you. So you can say, if you've got a card object that has a rank and a suit, you can actually say match card objects that have suit equal to hearts. So that kind of thing in if else would probably take 3 or 4 lines of code. Here, it's a single line and relatively readable. This is a bit of a contentious feature. I think it's anytime you add something like a switch statement from other languages, people get a little uncomfortable. My primary complaint with switch statements in other languages is they're giant foot guns. One of the biggest issues that you have is if you forget to put a break inside of a block, you might accidentally run multiple cases. So I am pleased to see that Python did not do that. So when you're doing a case statement, if it matches one, it will not run the rest. So that's far more foolproof than some other languages where I've used this. So it's an interesting feature. I suspect that it'll be a little bit like the walrus operator, that 5 or 6 years from now, there's going to be specific cases where it gets used. But otherwise, once the arguments calm down, people will just move on.
One of the things I thought was interesting, and I'm guessing this is related to the PEG parser improvement, the expression grammar kind of stuff, is that it doesn't, as long as you're using the correct formatting of the syntax, it doesn't forego you using the word case or the word match. Those are not keywords. Is that right? Am I getting the right terminology?
I didn't realize that. I had not attempted that. So I just assumed that they were in there in the syntax parser. So if they've done that, that's interesting.
That they've actually introduced a new class of keywords, so to speak, that they call soft keywords. And match and case are soft keywords that are kind of just keywords in certain contexts.
All right.
So you can still use match and case as variable names, for instance.
I think that was some of the worries, right? That you could have already, parts of your code that use the word match, and now like Python 3.10 would have broken things or potentially, gotten confused because there's suddenly brand new keywords.
Right. Yeah, and I think especially match has been used in regular expressions and things like this forever. So you can't really use that as a keyword. I think that would break everything.
Yeah. And so I like your term of foot gun, of like, potentially shooting yourself in the foot. I know you were talking about that quite a bit with the JavaScript course that you did.
Oh yeah, JavaScript. JavaScript's an entire howitzer. It's fun. It's amazing anybody has any toes left.
Right. I really liked there's 3 PEPs that are sort of included to kind of discuss this a little further beyond the article and the course that are there. So I'll include links to them. And I did like the PEP 636, which included a tutorial, actually, that'll be part of the Python documentation that you can kind of go through and look at it. And they had kind of a fun example where it was kind of doing a bit of a text adventure kind of thing. And so it had lots of different kind of matching and sort of ways that this would be unique and a little different than how other languages propose it. And then, showing off those features that you were talking about, where it can be a little more of a, detailed structure, of things inside of things that it's actually matching, which is cool.
Yeah, one of the examples, I don't remember which PEP it was, but they were sort of showing like a typical GUI interface where you're getting an event object, and that event might be from the mouse, it might be from the keyboard, it might be from the network. And because you would have each one of those events be a different class, you can just end up with a case based on that. And of course, you could do this before, but it would have been a giant if is instance this, if instance that. And it does, for these larger cases, become more readable.
I wonder if this will affect the world of testing in a large way.
It's possible. There was an article that I was reading this morning. They had gone through and done an analysis of some of the more popular libraries, and were trying to figure out what percentage of those libraries were big if-then-else conditions where this might be applied. And I'm sure they were doing it in an automated fashion because they were doing things like Django, which is too big to be reading casually over the weekend.
Right.
And the article claimed that less than 1% of Django is this kind of conditional block. I think there are cases where it's useful, but I don't think it's going to be, a revolutionary change to the language. I think it's, when 3.10 is getting to the place where it's end of life, and this feature has been in the language long enough that everybody who is using it has support for it, you'll see it in appropriate places, and in the meantime, it'll pop up in sort of specific conditions.
Did you know that 47% of Python projects include known vulnerabilities? And there are vulnerabilities in even the most popular packages, like urllib3, PyYAML, and Django. Luckily, 87% of Python vulnerabilities can be fixed, and Snyk makes it easy and free. Find out if your Python projects are affected by vulnerabilities, and get automated fix advice in your IDEs and repositories with Snyk. Create your free Snyk account at snyk.co/realpython. That's snyk.co/realpython. real Python. Moving onward to type hints, and this has been a topic that Geir Arne and myself have gone back and forth with, because I did a course based on his excellent article, like kind of getting people started in type hinting and type checking. So what are some of the improvements that they've added this time, Geir Arne?
So this has been a regular thing now, I guess, for many releases, that there are small improvements coming all the time. I guess the one that will be probably the most used and kind of most straightforward is that they're just simplifying how to specify union types. So if you have something that could be either one type or another, so say for instance you're working with a number that could be either float or int, then in the old days as of right now, I guess, you would need to import typing and then use typing.union to sort of like specify that this could be a float or an int. Now there's allowing you to just use the pipe symbol directly and say float pipe int directly. So no imports and nothing, and it will just be directly understood by the type checker. Interestingly, this syntax will also work in runtime checks, like if you're doing an is instance, and you can check for several types, which has been possible before using a tuple of types, but now you can also use the new union syntax for this.
Nice.
So that will definitely just clean up your type hints and so on. But yeah, unfortunately, it will be 3.10 since it's a syntax change.
Okay.
Then there's a couple of other PEPs that are sort of like, say, more niche uses of type hints, but one is that you can explicitly annotate something as a type alias. So that's something that's been supported for a long time, is having type aliases where you just essentially say that, for instance, in our number example, I could just define a new variable, really, that's number equal typing.union of float and int. And then later in my type hints, I could use number, just the variable name. Now, since these are just look exactly like regular variables in Python, it's been hard for the type checker to kind of really take advantage of these and always kind of make sure that what you're doing is really adding type hints and not just some variable that you're going to use. So they're just introducing a way for you to annotate these things as a type alias so that you can get even more help from the type checker. And then they're also introducing something they call type guards. And this is also kind of related to the union types. So for instance, say that you have something that could be either none or a string, say, or some kind of type. And then to kind of help or to kind of make sure that you cover all the possibilities of your types, you typically will have a check that says, if this variable is none, then do this. If it's not none, then do that. And the type checker can kind of recognize these things. So if you, for instance, do a none check and then introduce or you make sure it's a string, if it comes in as none, then the type checker will sort of like understand that, okay, now it's a string, so I can treat it as a string, and you can use your string methods and so on. This kind of works for your basic if variable is none or if it's an instance of something. But if you have more complicated things, the type checker will not be able to do this. For instance, if you have a list of strings or something like that, it's hard to make sure that it kind of works out. So what you will be allowed to in 647 is, in Python 3.10, it's based on PEP 647, is to define your own type guards. And again, you'll just annotate this as this is a type guard. And then you will be allowed to use those functions. And the type checker will then understand that, okay, now the type is narrowed down to whatever your type guard is guarding, essentially.
Oh, cool.
So both of these are kind of really nice if you need them, but most people will probably not use them, essentially.
Yeah, it's like these kind of special cases where this stuff kind of comes up.
Right.
Yeah, okay.
And yeah, the final PEP that also about type hints in 3.10 is something called parameter specification variables, which is some words combined, I guess. This is kind of, it's related to type variables, which is something that's been in the type system for a long time, I guess, since the beginning, where you essentially have a type that's not defined in your code, but it kind of just gets a value when it's being used. So essentially like a regular variable, but for types. And the way it's used is that you can say that, I have some function that can take in any kind of type, and then it will return the same type, for instance. So instead of then having to say that this could be, for instance, well, if you would call the input variable any and then the output any, then there's no real type checking. But if you instead define, I say that this is a type variable, I'll just call it t, is usually used. And then you say that, the input parameter should be t, and then it returns the type t. So that kind of actually does then type check that it inputs and returns the same type.
Interesting. So that's narrowing cases where it's trying to check to make sure that it's not going to, transmute something
right
from an integer to a float or a string to an integer or something like that.
Exactly. So this is kind of covering most of the needs that we have, but there are cases, for instance, and I guess the most big one is for if you have decorators or other ways of dynamically defining functions. Then for a decorator typically takes in a function with any number of arguments that can be any kind of type, essentially, and then it does its decorating, and then it returns essentially usually a function with the same signature. But with the current tools that we have in the type system, we can't really type hint decorators properly. So you lose type information if you apply a decorator to something. So what these parameter specification variables are is they're essentially just allowing you to do the same thing as with type variables, but for many parameters at once. So it kind of gives you an option to say that this thing can take in any number of arguments, and it should return the same number of arguments with the same types, essentially. Those kind of things.
It's funny that the other one was kind of more geared as guardrails. I feel like this one is definitely a similar kind of concept.
Yeah, I think it's kind of just ironing out some of the rough edges that people have kind of discovered are there. So we're kind of down to fairly niche changes in the typing system by now. And
do you feel like it would probably become a little less frequent, these additional updates then?
I think it feels like most of the big things are covered by now. So I don't know if it will be less frequent or just smaller and smaller improvements possibly.
Okay.
Because I guess now there are 4 different PEPs just on the type system, which I think is more than any of the other releases, but they're kind of smaller in a sense than maybe some of the previous years.
So Geir Arne, seeing as the annotations and the introspection stuff is sort of in the same area, do you want to maybe touch on those while we're talking about type-ins?
Right. So I guess, that's one of the things that have been... I guess you also covered this in one of the earlier episodes, the whole discussion on annotations and future annotations, essentially.
Yeah.
That were originally introduced in Python 3.7. There was this future import, which is kind of one of the ways that we can kind of introduce things that are not necessarily backwards compatible in a slow way, so to speak. And this was that the type annotations, or really annotations, they don't really need to be about type, but they usually are, would kind of be not evaluated while the code is being read, but kind of postpone evaluation of these annotations. And this is helpful when you have things that kind of end up being self-referential, or sometimes you want even annotations that may not directly make sense to Python, but it's something that the type checker should be looking out for and things like this. So this was introduced in Python 3.7, but kind of with this future import, meaning that it only works if you add from future import annotations at the top of your file. And back in 3.7, it was kind of jokingly said that this would become a main feature of Python without the future import in Python 4. And of course, by now, I guess people mostly agree that there will not be a Python 4 in a long time. So instead, at the last year's Python Language Summit, they decided, okay, let's make these future annotations part of Python for 3.10. And then as the feature was kind of moving forward, there was more and more testing done. And some of the bigger libraries that use annotations for runtime, so not the type checking, but at runtime, like Fast API and Pydantic, discovered that introducing this postponed evaluation had some big issues, essentially. And I think it's mainly due to that you don't, when you do the postponed evaluation, you don't actually have the correct context that everything was defined in. It's hard to recreate that for all cases. So kind of at the last minute before the feature freeze of 3.10, it was decided that, okay, we need to go back and look into this a little bit more. And then I think it's still on the books for 3.11 to include these future annotations as sort of like base Python, but it will not be in the current version though. There was a few things that were kind of added. One was a new function in the inspect module called get annotations. And this one is supposed to be able to read these annotations, both the future annotations and the current way things are working.
Okay.
Sort of like consistently. So if you need to use annotations at runtime, you should kind of use the inspect get annotations function to do it.
Yeah, that was like quite the little drama that went back and forth for a little while. I got a little heated. I was joking that it was like all these people on the sidelines of Twitter, like telling all the sides to like fight. And it was kind of strange. And so like, luckily cooler heads prevailed and everybody could kind of figure out, everybody's intent is good here. We just need to figure out how to, move forward with it. And,
yeah,
those kinds of libraries like Pydantic and Fast API, the typing is such a kind of, I don't want to say crucial, but like, integral part of like what makes them special and fast and able to kind of develop quickly because, knowing what you're getting and sending and coming back is pretty crucial with talking to all these different elements, especially web and databases and things like that. So the next one I thought we could cover is talking about a little bit smaller ones. There's some changes to how zip can be kind of defined now, right, Chris?
Yeah, they've so if you've not used zip before, this is a built-in function that will take different lists of things or anything that's iterable and combine them together. So if you give it two strings, because strings are iterable on letters, it'll give you a series of tuples that are the first two letters of the two strings and then the second two and the third two, etc. So this is handy if you're trying to manipulate data. So if you've got a series of lists that are the columns in a database, and you want to turn that into rows, then zip will combine these things for you. The problem with it is it's not particularly safe. If you have one of the lists not having the same length as one of the other lists, it just happily goes along and computes and hands you stuff back, and it may interleave it incorrectly or it may leave data out.
Yeah.
So there was a sort of fix to this a while back where they created a different function inside of itertools called zip longest, but they sort of still left the problem inside of the zip function. So what they've done in this release is they've added a optional argument called strict, and if you set that to true, it'll raise an exception if your sequences are of a different length. So it's a little safety feature, but it's not really on by default, so you kind of have to know that it's there and remember to use it. But it will prevent some pretty ugly and hard to find bugs if you remember to take advantage of it.
Yeah, cool. All right. So one of the things that has been interesting with the sort of the math and statistics modules there've been lots of these little additions over the last couple of releases, and this time they've added a handful of additional ones to the statistics methods. So, Geir, do you want to dive into those?
Yeah. So I guess the statistics module, I think that was included more or less at the same time I came to Python. So I didn't realize that it's not kind of been here all that long. But I think since Python 3.4, there's been a statistics module that can kind of do the very basic things like find the mean, find a median, and those kind of things. And they've kind of been quite explicit about the statistics module not being sort of like a competitor to some of the bigger modules like NumPy or Pandas or stats models or things like this. But it should kind of more just be your basic stuff, essentially what you could find on a graphical calculator, they've said.
Okay.
So they have kind of consciously left out a lot of things. But what they decided to include this time was essentially a few functions that can be used if you have two data sets that you kind of want to in a sense, compare or just find a relationship between. So you can find correlations or covariance, which is essentially the same kind of thing, or you can regress one variable against the other, so do a linear regression between two variables. So these are just added to the statistics module, and I think it's the first and the only functions that can kind of deal with two data sets, essentially. The mean and those kind of things typically take in one list of numbers and find the mean or find the median and so on. So for these things, essentially correlation just gives you a number that kind of tells you how does these two sets vary together. So if they kind of are essential, well, if you would find a correlation between the exact same things, they will have a perfect correlation or a 1 in correlation. And if it's just one is completely random compared to the other, you would have something very close to 0.
Okay.
So it gives you a good indication of these things might be related. And then, of course, there's the whole correlation and causation are two very different things. So it doesn't mean that one causes the other and so on, but at least you can find out if there is some kind of relationship between them. But yeah, the numbers won't tell you why that is.
Do you think this would be useful in, like, say, smaller data science or statistic type projects where you wouldn't actually want to grab another library?
Yeah, exactly. So that's kind of where it fits, right? Because if you're doing some kind of heavy statistical modeling, you're already using some of the bigger libraries. So it's more something that's easy to grab if you just having a few numbers needing to do some simple calculations. And I think, just having something like a linear regression function directly available in the standard library, definitely useful for a few for these kind of simple explorations. So it would be nice to have it there, I guess.
For this week's Spotlight, I want to remind you that Christopher Trudeau has created a video course all about this week's topic of cool new features of Python 3.10. In the video course, you'll learn about debugging with more helpful and precise error messages, using structural pattern matching to move beyond nested if, elif, and else statements, and match deep into data structures, adding more readable and more specific type hints, checking the length of sequences when using zip, calculating multivariable statistics, and working with asynchronous iteration, plus much more. I think it's a worthy investment of your time to learn how you can implement the new features of Python 3.10. Like most of the video courses on Real Python, the course is broken into easily consumable sections, and you get code samples for each of the examples shown. All our video courses include a transcript and closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. And that brings us to a couple other small ones. There's the asynchronous iteration. Chris, do you want to talk about that one?
Sure. So I think it was in Python 3.7, they introduced the concept of coroutines. And that is another way of doing parallel code. So this is a way of doing multiple things at a time on your system. There's two different kinds of parallel coding. One is CPU parallelism, multiprocessor parallelism, and the other is I/O bound. So a multiprocessor takes advantage if your computer has more than one processor, and it'll run different pieces of code on those two processors. I/O bound will actually work on a single processor because a lot of things, so your computer runs a lot faster than your disk, which runs a lot faster than your network. So most programs are actually sitting there waiting, doing nothing for a very long time from the computer's perspective. So I/O bound parallelism is the idea of, oh, you're waiting on doing something with the file system? Okay, let's do something else instead. So a coroutine is just another way of tackling this problem. So the coroutines include two keywords. One is async and the other is await. And you can make a function be asynchronous by declaring it async. And you have to use a library and map them up together properly for it to work. But the essential idea is you can run multiple of these things at a time. Now, the challenge is as soon as you have an asynchronous function, if it calls synchronous code, it's not asynchronous anymore because it has to stop and wait, and you're losing the advantage of being asynchronous. And two of the most common things that you're going to do is iterate over data. So if you're using the iter and next functions to iterate over some data, well, those are synchronous. So if you're using them inside of an asynchronous routine, this is a problem. You've now dropped out of asynchronous land and you're no longer taking advantage of the parallelism. So what Python 3.10 has introduced is two new functions. One is aiter and the other is anext. And these are asynchronous versions of the iter and next functions. So if you're coding inside of coroutines and inside of the asynchronous world, then you can now use these instead. And that will stop you from dropping into synchronous mode and in theory should speed up your code if you've got a lot of IO waiting inside of it.
So part of that was it was sort of protective of the iteration before, in a sense that it wouldn't want to switch in and out of those situations.
No, the code doesn't actually stop you. It just, so if you without thinking about it call synchronous code from asynchronous code, it'll just wait, right? So you won't give up the thread. You're stuck.
Okay.
And so essentially these are two new functions that say you don't have to wait on me. I'll come back. So if it's going to take me a while to get the next thing out of this iteration, then the thread can switch over to the other thing. It essentially is a freeing kind of concept. Whereas previously, if you'd included this inside of an asynchronous block, you would be stuck waiting on it.
Okay.
So this is, for people who do a lot of parallel coding, this is a beautiful thing. I did a whole bunch of work in university in this space, and the only thing I really, really remember about it is try not to do it. It's harder. It's harder to debug. It's harder to control. So if you truly are doing something where you really need the speed up, this is a very, very powerful tool. But it's not something I suggest people do prematurely. You want to be really sure that you've got a lousy synchronous code that has the ability to go asynchronous before you put in all the effort to go that way. But if you are there, if you're using tools like Daphne, Django channels, any of those kinds of things where you're doing asynchronous hits off of a web server so that you're serving multiple pages at a time, there's value here. It's just, it's a little bit niche.
Yeah, I recorded a show with Will McGugan to talk about his text framework. It's called a textual. They sometimes call it a TUI.
Yep.
And asynchronous has been kind of one of the things he's had to figure out in that. And we kind of related it to like the idea, like in some ways he has a background in games.
Yes.
and the idea of like kind of making this sort of game loop kind of idea. And I feel like, like it's sort of similar in that way that, there's all these things that are going to be happening. And then you have to overall pay attention and what's holding things up and, making things lag here or there. So it does become quite the issues.
And it becomes, even simple things. So the print statement, for example, is not thread safe. So if you are littering your code with print statements in order to debug and you're doing parallelism, you might just get corrupted output, and that's not going to help you. If you're using a debugger, you're going to stop one of the threads and not the rest of them, which will change the behavior because they're not all running at the same time. So you end up in race condition land, and bugs are far trickier to try and tackle. And in fact, so although the language for the last 3 or 4 versions have been putting in a whole bunch of features along this space, you still have to use third-party libraries to take real advantage of it, right? So the keywords are there, but if you want to manipulate files, you have to use AIO files. If you want to do web requests, you have to use, I'm trying to remember the name of it, it's AI-HTTP, I think. So there are third-party asynchronous libraries for doing this kind of IO-bound work. But so although the primary components are built into the language, the utilities are still very much outside in the third-party library space.
Yeah. One area that the next one we wanted to kind of cover was text encoding. What are the changes there?
I think this seems to be one of the sort of like running threads in the Python 3.10 is kind of giving you better options for debugging and finding errors. So this is similar to that one in that it will give you a way to find problems in your code, essentially. And by default, a lot of Python especially with Python 3, most of the text encoding is UTF-8, the Unicode, and if you open a text file, you will typically do something like with open the file name and then just specify that you want to open it. There is an optional argument that you can give there, which is encoding. And it turns out that if you don't give this encoding, what happens is that Python will use the preferred encoding of the computer or the user, whatever they have set up. And typically on Linux and Mac, this will be UTF-8, but on Windows, it's often something else. So this will then give you these hard and subtle bugs. If you share your code with some coworkers, they're running on Windows, suddenly the code that runs nicely on your computer doesn't run on their computer and things like this. So ideally, you would always just specify the encoding, and then the problem would not be there. You just say this text file is a UTF-8 file, so I'll just read it. So what they have added here is essentially just a warning that you can activate, either by setting a environment variable on your computer, or every time you run a Python script, you can add in with the command line option. And then it will just give you an encoding warning saying that the encoding argument is not specified at every point that you're trying to open a file without an encoding set. And this can then help you just clean up your code, essentially. And this comes a little bit related to back in Python 3.7, they introduced something called the UTF-8 mode, which is also something that you can set either with an environment variable or when you're running the Python interpreter. And in UTF-8 mode, it will just override this preferred encoding of the computer and always use UTF-8. So that's sort of like another way to kind of handle the problem. But in general, it just helps you write better and more safe code, I guess.
Cool. So then I think I have like two other ones. One was the way that they've kind of updated context managers to basically allow them to be contained within parentheses. I wasn't going to pronounce parenthesized. So yeah, what's going on there?
Yeah, this is kind of just been a sort of like a weird little, almost like a wart on the Python language, in that again, because of the old parser, it wasn't able to add parentheses when you starting with the with statement. So you couldn't do with parentheses and then whatever your context manager is, and then end parentheses, essentially because the parentheses would interfere with the context manager. I guess relative few cases where you either had a very complicated context manager or you had a list of context managers where you really wanted to kind of break your lines. You couldn't use parentheses like you can with most of the statements. To break your lines, you would need to use the backslash to break it off. So this is kind of one of the few places where you typically, or you might end up using those. So what they were able to do just when they introduced the peg parser in Python 3.9, that's the way I read it. It was sort of like a extremely low-hanging fruit to just make parentheses work. So this is actually something that has been working now in Python 3.9 as well, as long as you're using the peg parser. But because the peg parser was sort of like you could turn it off in Python 3.9, they call this a Python 3.10 feature that they kind of updated the syntax, and you're now free to add parentheses into your with statements.
Yeah. So the one other one that I have noted here, I don't know if you want to take this one, Christopher, is the Open SSL change.
Sure. So the Python compiler uses a open source toolkit called OpenSSL for a bunch of its underlying cryptographic functions. So if you're using hashlib, for example, or the SSL modules, those are using OpenSSL library. As with everything, the OpenSSL library has changed over time, and as it's changed, security has improved, and as a result, Python has decided to support a higher version for its minimum. So now, by default, you're after OpenSSL 1.1.1. So depending on how you get your Python, this might not matter at all, because if you're using a standard installer, say on Mac or Windows, then you're just going to get the new library built in and it's not a big deal. If you happen to be using certain versions of Linux where they don't install it, they use the system one, you might have to upgrade the system one in order to be able to use 3.10. So if you're on, I think it's Ubuntu 18 or either the Red Hat or CentOS 7s, they use an older version of OpenSSL by default. So if you want to use Python 3.10, you're going to have to upgrade your OpenSSL as well to get it to work properly. This is just, as things improve and become more secure, you want to be using the more secure library. So Python set a new minimum, and this won't impact most folks, or the folks that it will impact tend to be the ones who are playing around at the level where they'd be able to know how to fix it anyways. But it's kind of a little side note to know that this has changed.
Okay, good. Yeah, I mean, it's nice to see the progression there. So that brings us to the section of the big question: should you upgrade now? So I don't know if either you want to start off to give me your thoughts on that.
Yeah, I tend to like playing a little bit with the new features, but I think that Python is so mature now that you can usually fairly safely upgrade your interpreter to use the new version, and it shouldn't cause a lot of problems. One thing that I know has kind of been a small issue just when the new versions are coming out is that some of the other libraries that you might depend on, your third-party libraries, may not have released wheels for the new version yet. And the effect of that is just that it will try to install those libraries from source instead, so it will essentially install slower, or worst case, it might require you to have some compilers on your computer and things like this. So there might be in the beginning a few of the third-party packages that you rely on that will be harder to install. But apart from that, jumping over to using the new interpreter is usually not a problem at all. And often there will be some improvements, like for here, you'll kind of get the benefit of the better error message. For instance, there are some optimizations that are done for Python 3.10 that will run slightly faster and so on. But I guess the more interesting question to some extent is, should you start using the new features? So can you start playing with actually using the structural pattern matching or even the strict keyword in zip? And that, of course, depends on essentially how much control do you have on your environment. Can you make sure that the code that you're running will always be able to run on Python 3.10, or do you still need to support other older interpreters? So typically, especially if you're writing libraries that other people might depend on, then I guess it's good to still support the older versions. But if it's more like you're writing an app that will kind of just run on this Python, then it's easier to start using those features already. And of course, this really depends on if you're writing in say corporate setting together with others, then the team need to figure out what they're comfortable with.
Yeah,
so
totally.
But I think it's always great to at least a little bit on the side try out the new features and to kind of know about them, get them a little bit under your fingers.
Some of the ways that you've done that in the past was you had an article, and I'll link to it also here, of like if you want to dabble with these other versions, that Docker might be a good choice there potentially.
Yeah, that's what I often use myself. So when I've been researching this Python 3.10 article, I've just been running Python inside of a Docker. Yeah, it makes it very, unobtrusive. I'm not messing with my system Python that I need to depend on another. For some of my other things, are not even messing with my virtual environments. So that's a fairly straightforward way. At least once you have Docker set up, that could be a small hurdle. But once Docker is set up, running a Python within a Docker is quite straightforward.
Yeah. I feel like, I mean, this is without any kind of major evidence, but I feel like this yearly release cycle, along with the changes to the peg parser last time in 3.9, that the change to 3.10 actually might not be as big of a step. I don't know if I'm right in that sense, but I feel like in my own code and looking at different things that it seems like it should be a fairly smooth upgrade path.
Yeah, I don't expect any problems, but if you're going to start putting a new interpreter into production in any language, you should run all those unit tests that you've been a good little boy or girl and have been writing and maintaining all this time.
Right.
Because you don't want to be the one who discovers the weird corner case. But yeah, that's what testing's for. But there's enough here that I think that there's value in going for it. But to Geir Arne's point as well, right? A lot of it depends on your situation, right? So I'm still working on libraries that still support 2.7, even though it's end of life, right? So I can't even use fstring in some cases, as much as I'd love to, right? So that's always a balancing act, unfortunately.
So a couple things that we mentioned last year when we had the same kind of similar kind of conversation, we were warning about this version coming up of it being 3.10 and how if you're doing some kind of interesting checking of naming or checking of versions, that this might be something to be careful of in how you design your tests. So I don't know if, Chris, do you want to talk a little bit about that?
So the standard way of sort of checking what version you're running from within inside of your code is to either use sys.version or sys.version info. The sys.version returns a string, and sys.version info returns a tuple. And why this is important is string comparison is based on the ASCII table rather than on numbers. So 3.6 is actually greater than 3.10 because it sees the 1 in 3.10 and sees that as being less than the 6 in 3.6. So if you're using sys.version and a string comparison, you will get the wrong answer if you think you're using the minimum version. So the right way to do this is to use version info instead. It returns a tuple, and that tuple has the major and the minor version in it, and you can compare tuples. So 3.6 is less than 3.10 the way it should be. So you just have to be a little careful about this. The good news is several of the linters out there, including Flake 8, will look for this problem. So if you are in the habit of using a linter, which is a good idea anyways, it'll catch this for you.
Nice. Are there other things that you need to keep in mind in this upgrade path? I don't know if Geir Arne, do you have any other things that you included in that section?
I think it shouldn't really be a lot of stuff. That there's always some of these changes more down at the C level of the language. So if you're kind of writing C extensions, you should definitely have a look at that. There's a document called Porting Your Code to Python 3.10 that kind of lists all of these things. But if you're more writing pure Python code, then I think there's not really that much to worry about. There's a few things that are deprecated and removed, but those have kind of been really on the out of the language for a long time, so it shouldn't cause any issues. But as Chris said, it's always good to make sure you have tests.
Yeah, definitely.
The only other thing I would consider too is where are you upgrading from? So although 3.9 introduced the peg parser and 3.10, it only has the peg parser. So if you were skipping from 3.8 to 3.10, you are actually changing parsers. Now, as far as I know, it went fairly smoothly and there weren't many problems with it, but there is a deeper structural piece there. So if you're safely on 3.9, I don't think you'll have any problems. But if you're coming from something a little earlier, again, wouldn't hurt to test just in case.
Yeah. Okay. All right. Well, I want to thank you again for coming on and helping me celebrate this week of releases, for starting with the Python 3.10 release itself coming out, and then Geir Arne's article covering the features, and then Christopher's course, and of course this episode here, which is kind of wrapping up the whole week. So thanks again for coming on the show. I really appreciate it.
I look forward to chatting about 3.11.
Yeah, thanks for having me. Looking forward to next year.
Okay, thanks. And don't forget, you can automatically find and fix vulnerabilities in your Python projects for free with Snyk. Create your free Snyk account at snyk.co/realpython. That's snyk.co/realpython. I want to thank Christopher and Geir Arne for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.